My name is Dr. Onos. I'll be reviewing some MCQs with you guys for the MB prep. So question 1 says, one of the following is true concerning acid, base, and buffers. Option A says, equilibrium constant defines the tendency of an acid to gain. Acids do not gain protons, they lose protons. So this gain makes option A wrong. pH expresses the total hydroxyl. It's not hydroxyl ion, but actually hydrogen ion concentration. So this makes it wrong. Buffers are most effective when pH is less than pK. Actually, it's when pH is equals to pK. That's what we have it. And that's what D says here. Buffering capacity is highest when the concentration of proton donors becomes equal to that of the proton acceptor. So option D here seems to be the correct option. Question 2 says, the following are body buffers except oxygen is not a body buffer, but bicarbonate is a body buffer, hemoglobin is a body buffer, and phosphate, is a body buffer, and bicarbonate as well. So B is the odd one there. Question 3 says, regarding the bicarbonate buffer system, which of the following is correct? They say it is the least important extracellular buffer. That's wrong. It's actually very, very important. Option B says, increase in lactic acid in the blood leads to increased exhalation of CO2. Yeah, this would be the, just think about it. Once you start to exercise, lactic acid builds up inside of you. Your normal response is that your body starts to hyperventilate, so you begin to increase exhalation of CO2. So this statement is actually very correct. Option B is correct. This says increase in ammonium, or ammonia rather, produces production leads to increased exhalation of CO2. That's wrong. It will not lead to exhalation of CO2. Under physiological conditions, the ratio of bicarbonate to carbonic acid is 1 to 20. It's actually the reverse. It's actually the reverse case here. So this is actually wrong. So option B is correct. Question 4 says, which of the following is correct? Carbonic acid is a triprotic acid. Carbonic acid is H2. Let me write it here. Okay, let me bring it down here a bit. It's H2PO3. So this is a diprotic, not triprotic. Phosphoric acid is H3PO4. Is a triprotic. So question 4, acetic acid is a monoprotic acid. That's very correct. So that's CH3COOH. So this is a monoprotic acid. So sulfuric acid is diprotic, not triprotic. So this is wrong. So the best option here is option C for question 4. Question 5 says, one of these is false. A constitution of strong base is usually unknown before a titration. No, it's usually known. A strong acid that is not known. So this is actually wrong. So option A is wrong. So the strong base is supposed to be acid. So the strong base is unknown. That's wrong. Strong base is known, but strong acid is unknown. The titration curve reveals that the weak acid and its anion can act as a buffer. That's true. The pK of a weak acid can be gotten from the titration curve. That's true. And an indicator dye is used in titration. That's also true. So option A is false. Question 6 says, which of the following is true about the strength of an acid? The lower the pKa, the stronger the acid. That's not true. The lower the the lower the Ka, not pKa. Ka and is actually the Ka is directly proportional to the strength of the acid, while the pKa is inversely proportional to the strength of the acid. So the lower the K is supposed to be, the weaker the acid. The lower the pKa, the stronger the acid. This is actually correct. Option B is correct. She said the higher the pK of the acid, the stronger. That's wrong. The higher the K of the acid, the weaker. No, that's actually wrong. So B is correct. Question 7 now says, at the point of maximum buffering capacity, pH will be equal to pK. We said that already now. That's correct. So that's option C. Question 8 says, regarding a mixture of strong base and strong acid, one of the following is correct. Regarding a mixture of strong base and strong acid, I'm down here. One of the following is correct. Question 8 is actually option B. Has no buffering power. So a mixture of strong base and strong acid will have no buffering power. So that's the correct answer there. So question 9 says, when a small amount of hydrogen ion or hydroxyl ion is added to a buffering system, the ratio of the buffering components changes. So when a small amount of hydrogen ion and hydrogen ions is added to a buffering system. Question 9, I think I'll go option B. The ratio of the buffering components changes. The sum of buffering components changes, that's false. It's the ratio that changes. There's a huge change in pH, so that's false. The best option will be option B here. Question 10 says the H2PO4 minus ratio HPO42 minus pair has a pK of 6.86. It is an effective buffering approximately, so we need to say it's 6.86 plus or minus 1. So minus 1 from this, you're going to get 5.86. To add 1 to that is going to be 7.86. So that's approximately 5.9 to what? 7.9. So that's option D will be the correct answer here. Question 11 says, the first line of defense against changes in pH in an organism is the buffer system. That's the first line of defense. So that's the buffer system, option C. Question 12 says, the pH of plasma in man is about 7.4. The range is 7.35 to 7.45. So the average is 7.4. Question 14 says, the pH at which enzymes show maximum catalytic activity is actually called the optimum pH. That's option C here. Question 15 says, the repeating disaccharide unit of cellulose is actually cellulose. Inversion is related to which of the following? The answer is actually sucrose. Sucrose is known for inversion. Saliwanov's test is answered by which of the following? Fructose is what we use for Saliwanov's test. The sugar residue of amylose are what? Alpha 1 4 linkage. It's a cellulose that is beta 1 4 linkage. So 18 is actually C. Mucic acid is produced from oxidation of galactose. So that's what forms mucic acid. And protozoa in seminal fluids utilize the following sugars for metabolism. The answer here will be fructose. Fructose is utilized by protozoas. Spermatozoas, I meant to say. Spermatozoa in seminal fluid utilize the following sugars for metabolism. That's actually option D. Question 21 says, which of the following does not give a positive test for reducing sugar? So the odd one here will be sucrose. So sucrose doesn't give a positive test for reducing sugar. Question 22 says, which of the following does not contain at least one hydroxyl group? The correct option here would be oleic acid. Oleic acid does not contain at least one hydroxyl group. So that would be odd here. Oleic acid. Question 23 says, cellulose is a straight chain polymer consisting of beta 1 4 glycosidic unit, option B. And question 24 says, for a compound to possess optical activity, it must be symmetrical. So that's the best option. It must be symmetrical, option D. Question 25, hydrolysis of sucrose will yield fructose and glucose. That's question 25.